Here we're asked to write the following expression using summation notation. So summation notation here, we're going to do a couple of things. First of all, what I should notice about each of these pieces here is that each time that I am, adding something new, some of the stuff stays the same and some of the stuff changes. So the 0.25 is happening every single time I'm multiplying by 0.25. I'm also squaring everything every time. So the 0.25 is going to stay the same. I need to figure out what goes inside there, but then my squared is also the same. The reason that I put these parentheses here is because the stuff that's in parentheses keeps changing. Anytime something in the expanded form changes, it means that I'm going to have a variable in that piece. And the hard part is to deal with how do I find the equation that represents this changing piece. So to do that, I often recommend kind of drawing a table here, because if you remember for sigma notation, we are going to use some variable. I'm going to call it k, and we're going to start at some number. I usually like to start at 0, but you're welcome to start at 1 or whatever number you prefer. So the reason I start at 0 here is because it helps me make this equation much easier. When I'm going through this here, I'm basically saying that when I plug in 0, the first time I plug in a number, I'm going to get 3. So when I plug k into this equation, it needs to be equal to 3. So I know that this is 3. Then I look again, I can kind of create this table 3.25. That's when I plug in 1. Then 3.5 when I plug in 2, and so on until I get 5.5, and my last one is 5.75. So I can kind of create this table, right, that has some of these values. The reason the table helps here, I'll call this x of k, is because when I'm looking at my equation, I see here that it is a linear function. It's going up by the same amount each time. It's going up by 0.25. So that means that that is my slope, meaning it's a linear function. And when I plug in 0, this is why I choose 0 to start with, is that when k is 0, well, then I have to say that my y-intercept would be 3. So that's why starting with 0 is usually the easiest, because if it's linear, then my first value becomes my y-intercept, or whatever I add. So now I'm going to take this and I'm going to plug that into this piece here. So now I got, let me erase this here, 0.25k plus 3. Let's just double check and make sure that that works for the values that I know. So if I plug in 0, 0 plus 3 is 3, which is good because that's where my first number is up here. If I plug in 1, 2.25 plus 3 is 3.25. Good. If I plug in 2, that gives me 0.5 plus 3. Okay, so my equation is good. I'm almost finished. The only thing I'm missing now is this value on the top. And to get that, I know my final value that goes in the parentheses, right? So really, I'm just going to say, I'm going to set these two things equal to each other. So 5.75 equals 0.25k plus 3, and solve for what is my last k value here. So in this regard, I subtract both sides by 3, and I get 2.75 equals 0.25. And then I divide both sides by 0.25. That gives me my answer of 11. So 11 equals k, which tells me that my top number here is 11. So a lot of steps in this, but let me just recap it here. The first thing that we did, right, is I found what was consistent every time. So 0.25, 0.25, 0.25, and squared, squared, squared. So that became part of my equation as a constant. Then from there, I looked at what is it that is not constant, and that was what's inside the parentheses here, underlined in red. And so what I did is I created a table with k, the variable I'm using, and x of k, which is the stuff that ends up inside the parentheses, and I found an equation from that. My recommendation is to try and start with 0 because it makes finding this equation much easier, in my opinion. Then the last step is once I've found that equation, I plug it in And then from there, I have to find the final k value by saying like, oh, I know 5.75 is equal to all of that when it's my last k value, and solving for k.